class, I'd like to cover your final exam review and first some suggestions on how to study. Do the following problems that are in this document. Redo problems from the old test. Redo questions from extra credit quizzes and practice problems on iCollege. And there are, if you look under in iCollege, under your assessments, under quizzes, there is a final exam review practice problems. So that would be really good too, and it has the answers. So there's a lot you could do to study for the final exam. The final exam will be on iCollege, and I believe I posted the calendar of when the final exam will be. So we had a lot of types of equations. We had quadratic equations. So you'll need to know the quadratic formula. You'll need to be able to solve quadratic equations by factoring, using the square root property, and using the quadratic formula. So what I have in this document are some problems for you to try and the solutions. So these are all quadratics. This one you could use, you could get it into the right form and use the square root property. And this one you would need to use quadratic formula, and same here. Now you may have non-real answers with the I, and be sure that if it says to simplify, that you simplify as much as you can. Okay, and we had rational equations. So remember, the steps are to multiply by the LCD, check your solution, that your solution does not make the denominator equal to 0, and some examples with the answers. What is it doing here? Okay, radical equations, and the way you want to do that is isolate the radical, square both sides, and be sure you check for extraneous solutions. Here's an example with the answer, so please try that one. And then we've got higher degree equations, which you would solve by factoring. This one is in the form of a quadratic. This one has 4 terms, and so you would factor by grouping. And please try these, and here are the solutions. So these are just more for you to try. And then we've got rational equations. So you would multiply by the LCD and check that your solution does not make the denominator equal to 0. I think I already had covered that. Let's see. Higher degree equations, already covered that. Exponential equations, you want to isolate the exponential, take the natural log of both sides, use the log property to bring down the exponent. Here is an example with the solution. We had log equations, so you want to get a single log using the properties of logs and rewrite in exponential form, and then you have to check that your solution does not make you take the log of a non-positive number. Whatever's in the argument must be greater than 0, and here's a couple or several examples with their answers, so please try those. What happened next? Oh, exponential or up there. Okay, inequalities. The way that we did this in class, we changed this to set it equal to 0 and find the boundary numbers, and then we used test values to figure out when the inequality was true. And then you will need to be sure you write the solution set in interval notation, and be careful with that because you know, whether you put a square bracket or parenthesis does make a difference. So here's a few that you can try. And so we had polynomial inequalities, and we also had rational inequalities. And remember that for rational, you find the boundary numbers by setting the numerator equal to 0 and setting the denominator equal to 0. But you never include the vertical asymptote, which is what you get when you set the denominator equal to 0. Never include that in your solution set. And then we got into functions. So determine whether a relation is a function or not. If you've got the graph of it, you could use the vertical line test. So this is not a function. If you've got the equation, remember if y is squared or y is inside a square root, it would not be a function. So remember, you know, what it means for a relation to be a function. Find domain and range of a function. So for this function, x can't be 0 and x has to be greater than or equal to -1. And so it works out, if you write that out, this is the answer. This is the domain. Determine the intervals over which a function is increasing or decreasing and constant. And when you've got the graph of a function, you can determine the range. So like in the range in this function, it only goes up to 1, but it keeps going down. Find the x and y intercepts of a function. Find the zeros of a function. Find the average rate of change of a function using this formula. Be able to evaluate a piecewise function. And be able to use the difference quotient. And this is the formula for the difference quotient. Be able to find the composite of a function. So like given f and g here, you want to find f of g of x, and this is the answer, and then this is the domain. Determine if a function is one-to-one, and you can use the horizontal line test. And this is a function, but it is not one-to-one because the horizontal line test would cross it more than once. And then find the inverse of a one-to-one function. So remember the steps for finding the inverse of the function. And then you might have to find the domain and range of the inverse. Determine if a function is odd, even, or neither. So remember we put f of x into our function. And I mean, we put a negative x into f of x. If we get back the same thing, that means even. If we get back the opposite, that means odd. Okay, be able to put a quadratic function into vertex form, and so you need to know what vertex form is. And then when it's in vertex form, this is the vertex. Be able to determine the axis of symmetry and whether the graph opens up or down, and find the intercepts, the x and the y intercepts. This is the function in vertex form. This problem asked for that. This is the vertex. A word problem involving a quadratic where you need to find a maximum or minimum. And remember that the x value would be where the maximum or minimum occurs, and the y value would be what the maximum or minimum value is. Now you can use these formulas on the word problem. So this will give you the x value of the vertex, and this will give you the y value of the vertex. Polynomials, find the degree, the zeros, the x and the y intercepts. X intercepts are just the zeros. Here's an example. And be able to determine the end behavior. So once you've got the leading coefficient and the degree, you can determine the end behavior. This is how, you know, to get the leading term, it would be this times the leading term here times the leading term here. Let's see, rational functions. The big thing were the vertical and horizontal asymptotes. So I should probably write in here horizontal asymptotes as well. And be able to find the intercepts and the domain. So here is an example, and you can work it out, but these are the vertical asymptotes, and this is a problem for you to work out. Okay, I didn't work it out. Here are the x-intercepts and the y-intercept and the domain. Transformations, be able to describe and graph transformations. So be able to describe and graph transformations. Equation of a circle, put the equation of a circle in standard form. You need to know the standard form of a circle. Find the center and radius. Here is an example. Remember, we had to complete the square on this, so be sure that you practice that. For lines, be able to write the equation of a line in slope-intercept form. Be able to find the slope of a line. Be able to find the equation of a line that is parallel or perpendicular to a given line. So remember that parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. Logs, be able to evaluate a log and rewrite a log in exponential form or vice versa. A word problem, possibly a compound interest problem involving these two formulas, or another kind of exponential growth or decay problem where the formula would be given. A word problem involving a quadratic, we already mentioned that. And then the last couple of things, solve an equation using substitution and or elimination, and recognize when there is one solution, no solution, and infinitely many solutions, and solve a system of equations with the matrix. So I believe that does it for the review. I know that's a lot, but you can start studying for your review. See you later.